Well, hi, good morning, and thanks so much for joining me here in my shop today. Let's see, what's the date today? I took yesterday off. Today is the 11th of May. And what I plan to do today is perform the alignment process on this radio. And it would be the first time I've tried to align this radio in any serious way. And I've learned from experience to just accept that the first time you try to do an alignment on a radio like this, it's kind of just a chance to learn everything, and chances of getting it really right is kind of low. So you just kind of got to accept that you're going to align a radio like this a couple of times probably. At this point in the process, by aligning it, I'm kind of removing alignment problems as a cause of any bad performance. So after we complete that, we should be getting maximum ADC voltage and stuff like that. And then we can go back to checking some more things in the radio and seeing what's up. Now, the radio's still on its back here because I really wanted to look and see if any of the alignment adjustments required access under here, and they don't. Boy, this is really not very good. Really not very good. There's a cracked wire coming from the outlet. It's just every time I turn the radio upside down, this is going to move a little bit. Maybe I'm just going to extend a little bit of black tape on that just to make me feel a little better. I won't even use black tape. I'm going to use, because applying black tape will strain the wire more and probably crack off even more the insulation. So I'm just going to try to tuck some, yes, drafting tape around it here. This is probably not going to be a good idea either. Yeah, this is not the best idea, but better than nothing. So that's going to provide some physical distancing in there. That's much less likely to short out. Oh, this is terrible tape. I picked the worst tape. Painter's tape. Well, okay, I feel better anyway. So all the adjustments are done above. And, some of them are right here, right on these things here. Let's flip this up now. So the adjustments are, there's a whole pile of them down here, a string of them along there. Of course, you have the two IF cans here. Side, there's a couple in the front here, and I think that's probably it. I just stick my camera right at the back here and see. No, nothing on the back. So that's what we've got mainly, those guys there. 1, 2, 3, 4 I can see. 5, 6, if you count the two in the front. 6 trimmers. But what about right on the capacitor itself? I didn't really look at that. So very often there are trimmers mounted right on the capacitor. You can see these are not being used. These are just terminals. These two are terminals. Look at how dirty that is in there. Oh my gosh. The plates, they're so dirty. It looks like one mass of metal. Probably this dust doesn't really do anything. You know what? These are not plates. What are those? What are we looking at there? I've got to change the focus on my camera if you want to get in there really close and look at those. What is that? It almost looks like a spring. Okay, hang on one sec. It's going to take me a moment to, I have to call up the focus dialog box. I'll let you look at that while I do it. I'm clicking away over here on my computer. Okay. I'll force the focus in close. Oops. Okay, let's switch back to the other camera. Okay, what are these things? It really looks like a spring. Or is it like a hinge? How can it be a hinge? It's in the wrong spot. Let me tune the radio and we'll see what these things do. They don't do anything. Well, I've never seen anything quite like that before on a capacitor. Is it? Is it just the way they've attached the stator plates? Is it just like the stator plate? They certainly do seem to line up in a pattern with the... I don't know what they are. Maybe I can get at them another way. Yeah, I can come down this way. Let's look at this one here. Well, I guess it's just some manufacturing thing about how they made the capacitor, and I don't really know what they've done here. But I've never seen it quite like that. I think it's immaterial, though. I don't. Well, how about the other? Maybe the other side has the same sort of deal. Well, it does. It does have the same thing. Just curious about something I've never seen before. That's what's happening here. Okay, let's tune the radio. Well, it just looks like the way in which the plates are supported or held or something. I don't know. Okay, just very curious. Okay, enough of that. So to do the alignment, there's two large stages. The first stage is the IF. I normally do the intermediate frequency transformers. That's these guys back here. Guess what? This doesn't look original. No, this here we go. This is not original. That's the original size, and if you look, this looks different, first of all, and secondly, look down around the can. You can see the outline of the larger can. Now, I've done this myself in a radio, changed one of these, and it did work in the end. I'm guessing it probably didn't work as well as it would with the original can, but it worked. So, now, if somebody's going to do that, has to know an awful lot of what they're doing before they do this. We better flip this back up and look under here and see what actually happened, and get another look at it. Let's do that. Okay, radio. Okay, and so the changed. Oh, well, there's nothing here. Oh, so that explains it. Now, yeah, explains what? So I noticed this red wire earlier, and I thought, well, that just doesn't look original. It just looks too clean and too new. And that's going up into that IF can, and then over here is a black and a green, yellow and a red. You know what I'm going to guess? I'm going to guess that a repair shop stocked these. And in cases where one of these was defective in a radio, they would bring their stock one off the shelf and stick it in. And it comes with the different colors of wires to help realize which wire's which. Whereas on one of these, like this one, you know, well, you know what, the wires are definitely colored on the original ones too, but the color kind of gets faded and lost. See, it's all cloth covered rubber insulated wire, but not these. These ones are plastic covered. So okay, there can be no question. This thing has a new IF can in it. Now, what does that tell you about alignment and stuff? I don't think it makes much difference really in the procedure for doing alignment. Which, by the way, I have not read because it's on page 106, and I've only got page 107. So a good idea would be to read the instructions, although I can kind of guess what they're going to be. Okay, so I guess I buggered up the pointer because that's the end of the run there. This pointer should be way over here. Yeah, it just slides on the string. There's a couple of start marks right here. I'm pretty sure. Some end marks there maybe. Let's see. I'll line it right up on the start marks. What I think are start marks. What's the problem now? Oh, I bet you the string is bunging up here. Yeah, this has got a string bunging problem here. The string is wrapping on top of itself. It has wrapped on top of itself. This is how you break a string. Wrapped on top of itself again. Okay, and it stops right on the stop marks. No little dots. Good. A lot of radios, putting the pointer in the right spot on the string is a bit of a challenge. Okay. So where are we at now? What am I doing? So I'm going to continue with the alignment. I'm going to read the instructions. I'm going to find and read the instructions. Hey, that'd be a good idea. Okay, so now we're looking at the alignment instructions. You know, these are fairly generic, so it actually goes with quite a few different radio models, including mine. So look, it's 1, 2, 3, 4, 5, 6, 7 stages or steps. The last step says wave trap. The wave trap, and you see the frequency generator is set to 455 kilohertz. That's the IF frequency. So the wave trap is a filter designed to prevent 455 kilocycles from going out the antenna or coming in through the antenna. That's usually what that's doing, which is why it's called a trap. So with that sitting there, and assuming it's tuned properly, I should not try to ram 455 kilohertz into the IF right through the antenna. That's not a very wise idea. Let's just go take a look at the schematic again. Yeah, so there's no front end RF tube in this radio. It's straight from the antenna, straight into the mixer tube. And the grid we would want to get on would be grid pin 1 to inject our own, not 1 but 3. We want to get onto pin 3. Let's see what it says. Oh, it says right here. There it is. Grid of 6K7. Well, in fact, yeah, that's right. What am I thinking? You don't want to get on the grid of this tube. You want to get on the grid of this tube and then do this transformer. Then you back up, inject into this tube, and then do this transformer. Is that what it says? Band switch setting string left. Dummy antenna. We'll talk about that in a sec. Connect the generator. This one here, grid. Yeah, so that's what they're doing. So you're just trying to feed the signal through the particular transformer you're adjusting. Dial setting, frequency generator, adjust trimmer, second IF, C11. Well, isn't there two? Like C11 and C12? Shouldn't that be what that is? Look over here. Oh, okay. So they're calling this whole thing C11. And then the other one must be, of course, first C10, first one. First and second. So we want to get on the grid of here. That's easy because these have, wait a minute, this radio, yeah, that tube has a grid cap. Quite easy then. We just feed the signal into the grid of the 6K7. That's why it doesn't have a pin number here. There is no pin number. It's a grid cap. And then we do this transformer. Now, where are we? Maximum output where? Output where? Now, quite often what you're doing is just reading the voltage on the speaker and listening to it too. And usually have a note somewhere, I'm looking for it, that says where to hook up. Is there any hint here? Rock back and forth, check for image. Maximum output. So the options we have here is to monitor the ABC voltage or the rectified output of the IF. We can monitor that, which appears to be in trouble, by the way, in this radio. Or we can monitor the volume level, and in fact, you know what, I can do both these things. Why don't we do both? I'll hook a meter up to the speaker and I'll hook a meter up to the ABC. Now, where do we want to get the ABC from? So I'm going to come over here where the ABC voltage is created, right on these diodes here. And a good spot would be, oh my gosh, well, this is a different radio. Don't look at this radio. This is the wrong radio. It's got the right alignment instructions, but wrong radio. Okay, hold on, let's get the right radio. Whoops. Okay, this looks a little more familiar. Here we go. So again, starting with the two diodes. Down here, you know, probably the radios are very similar. They just have the layout of the resistors different. This would be a low impedance point I could attach to. I could come to the top of the volume control. That's a typical spot for picking off this voltage. Would not want to go on the other side here because it's starting to affect the meter might be a little too much for the impedance out here. So we'll put the meter on here. When we do it, we can check to see if it's influencing the radio negatively, but it really shouldn't. It really shouldn't at all. And this represents the top of the resistor. What, R7? How much is R7? R7. 50,000 ohms. 50,000 ohms here. I could go either side of this resistor. So this might be the easiest point, just a terminal on the volume control. That'll give me the ABC and the speaker. Let's look at the speaker now. Where's the speaker? So, so this is the actual speaker here. Here, really. Voice coil and I believe a hum coil being shown here. And they don't tell you which is which or what is what. What I'm looking for is some connection back to ground, and what I'm seeing is this, back to the chassis rather. So that matches up with this, oh, right to the chassis. So that means there's a bit of an issue with how I hook up my voltmeter to the speaker. So I do it the wrong way. I will put another. So this is a ground back to the chassis. Yeah, think hard here. I'm going to use two instruments. Ground them both to the chassis. Yeah, I can ground both instruments to the chassis, and then I can pick up the speaker with the other lead. That really shouldn't be a problem. It shouldn't be a problem. Okay, shouldn't be a problem. Probably will be though. One problem is I have to hook up underneath the radio to get at that key point. The you know, getting on the grid cap here is no problem. It's getting at that other location. So maybe another reason why when these radios are being aligned, the instructions are hook up to the speaker and not to the ABC point. The ABC voltage comes up onto all these grid caps, or some of these grid caps, but the circuit is too high in impedance to get in there and steal a little bit of charge away for your meter. It's not going to work right. Well, let's hook up the. You know, I'm gonna stop. I'm gonna hook all this stuff up. It's gonna take a little while, and then when I come back, we'll be ready to do the actual alignment work. Okay, now the ABC spot. So we can start with the volume control. 3 prongs coming off of it. One will be connected to the chassis, and that's the one up in the back here, right to this chassis terminal. The middle one is the output, and that's going on to the amplifier. That's going through this capacitor back here down to here. The last one has to be the connection I'm after. That's this one, which goes through a resistor. Here's a resistor, and meets up with some other components, and there they are down there. So if I wanted to, let's see, so the green wire here, which is coming to this terminal, is coming out of the IF transformer. So it all adds up perfectly. So I can go here or here on my ABC meter. The meter I'm going to be using is this one. So we'll switch them on, and it's high impedance. So I'm going to attach a clip lead. We're going to start up here and attach it somewhere where it won't wander. Okay, and then we're just going to have this come out from underneath the chassis. Okay, and I'll just clip this onto my voltmeter lead. So the kind of voltage we're expecting here is minus voltage, maybe as high as 15 volts. That's what it should be, I think. What's really happening, looks like it's minimal, maybe a volt or two, very, very low. Again, that could just be an alignment issue. So I got this meter hooked up to the speaker. No, I don't have this hooked up yet because I have an issue around the ground connection. The ground connection from the meter here, just go right on the chassis, like that. And this meter, which is just reacting to noise on the open wires here. Got to go on the speaker, but one lead here, this is tied back right to power system ground, and so is this. So I want them to be the same thing. Didn't I determine I could hook this up right to the chassis and then find the output with the other lead? I think I figured that out. I'm gonna do that. As soon as I find a good spot to clip this. Good spot. Way up here. Okay, here's a spot. Okay, and then we'll guess. Take a guess at the ungrounded lead here on the speaker. Ungrounded voice coil lead. Maybe I should wait. I'll wait till the radio's operating. Yeah, that's a good idea. And we'll complete that. So I should have my signal generator going. And that's you know what? I missed hooking up the signal generator underneath. No, it doesn't have to go underneath. It doesn't have to go underneath. I have another ground, but this one for sure. Just go on the chassis here. We'll go with this guy. And this goes on the cap. And it talked about, didn't it talk about a dummy antenna? Let me just look back at the instructions here briefly. A dummy antenna. It said dummy antenna 0.1 microfarads. Now I learned from experience that the dummy antenna term is used kind of loosely in this situation. Sometimes when they say dummy antenna, I think they mean to put it right across the antenna leads. Other times when they say dummy antenna, they really mean run the signal through this component, which they're calling the dummy antenna. And often it's not so clear. in the instructions here. So what do you think they mean here? Dummy antenna point 1. So the very next thing in the instructions, right here on my computer screen, is connect generator to grid. Dummy antenna. I don't know what it means. So you kind of want to hook up the signal generator through a capacitor. Is that what they're talking about? Dummy antenna at that point? Here's a capacitor. Well, I'm going to do this anyway. So the signal generator signal will reach the grid through a capacitor. Now, as for putting a dummy antenna on the antenna leads are over where? You know, I'd be more inclined during this stage, you can't see them, to just short these guys together. But again, we can experiment a bit and get there. Now, we need this to be set to 455. 460 is a good start. I think we're ready now to fire up the radio. Let me just double check everything. Let's get the eye where we can see it, because it's going to be of interest also. Where can it sit? Sit like that. Sit kind of like that. Kind of like that. Okay, I think that's okay. You can see it a bit there if we need to. Volume down. Tone doesn't matter. Plug is in. Speaker's plugged in. Speaker connection waiting to be made. AVC hooked up. Meter ready to go. Scale's a little high. We'll put the scale on 50 volts here. Signal generator is going with a very high output. Let me knock it down. Okay, and then I just stepped on a wire and almost yanked everything onto the floor here. Okay, here we go. Power on. Okay, switch is on, dim bulbs in. Whew. Okay, we got past that stage. Up. Now it is running on with the bulb in there. It's 100 volts right now, going down. As the radio draws more and more current, the supply voltage go down and down, and this thing will get brighter and brighter here. No need to have the bulb in anymore. And there we have some kind of sound. That's enough to get this sorted out and make this a little more sensitive. Now, one of the voice coil connections is right here for me to get on right away. Let's see what happens here. Can I get there? Well, doesn't seem to cause any problem. Funny sounds coming out of that radio. What was that? Oh my gosh. Really trying to do things with one hand here. Get on that. Ah! Okay. Some fairly... Okay, I think I've done it. Oh, look at that meter. Let's see. No. So on a 1 volt scale, that's an awfully high reading. So I think something's gone wrong here. Maybe the connection back to the chassis. Well, that didn't make any difference at all. Let me connect this wire to the other voice coil terminal here. I know what it is. I know what it is. This is a replaced speaker. And whoever wired it up, or the speaker itself, doesn't have that connection, that ground connection, or chassis connection, back from the voice coil. That's why I'm not seeing any effect from that. I think we probably got it now. Still doesn't look very good, does it? I really hope this would be lower. I'm on a 0.1 volt scale now. Well, let's go with what we got here. We'll see what happens. So I have the signal hooked up. We should be hearing it. If the IF is anywhere near 460. Magic eye is nice and bright. It's almost too bright. Nobody home? Nobody home? More power. Not a sound. Volume up. Volume's up. We're hearing it. What's going wrong here? Okay, more power. Wow, barely hear it. Something's fishy about this. Something's not copacetic. Let's look at the AVC voltage here and see what it's doing. Okay, I'm just going to tune that signal generator back and forth a bit. Oh, that's kind of weird. So, in fact, the peak, maybe, you know what, maybe I don't have the, I have no modulation. That's what it is. Last time I ran this signal generator, I used external modulation. Okay. So, what happened here? I just stupidly blasted a heck of an audio signal out of that radio, and listen to it. It's far louder now. How's that happen? I don't know. It's this radio's sensitivity just shot through the roof. So dirty could have been as simple as a dirty volume control. I don't know. Something woke up. That sound you're hearing is me doing this. Yeah, there's a ton of volume now. There wasn't before. So let that be a lesson. Blast your radio once. It's kind of like stomping on the gas pedal to kind of blow the carbon out of the engine. That must be what happened. Okay, carbon-free radio. Let's turn this thing down before I blow my ears off again. Turn this one down. That's really where the ear blowing's coming from. Okay, I'll turn on the modulation again over here. For some reason my modulation's super high. Okay, 30% modulation coming from there. 465 is the frequency that it's tuned to. There's what we hear. Now, what is going on over here? Oops, that's not going on. Just trying to get this meter a little more in view. Camera. Terrible. Oh, nice. Just more general lighting here, maybe it'll help. Okay, so AVC meter, tuning back and forth. That's just doing absolutely nothing. Pretty sure it's connected, so we're going to increase the signal level over here, and I don't want to blow my ears off again. Did this come up at all? I don't think so. Now this shouldn't do anything. Right. And tuning the signal generator. I don't think I can get everything on camera here at once. No, I can't do it. So just watching the meter, tuning the signal generator. So it is moving a little bit. Let's make it more sensitive, then we'll feel better about it. I would put that right at the top of the ABC meter setting, and the number is 464. Subtract 1, 463. Now, is this thing at maximum at the same spot? Which is really what I want to check. Whoops, let's just put this like this here. Watching this meter, notice the sound is distorted too, but let's just see. One way, down. Other way, yeah, it's pretty much the same thing. It shouldn't be any different than what the other meter's doing, but you never know. Okay, so we're all set. We're set to do the alignment here. I can back down the signal strength, coming over the radio here a little bit. Okay. We want this to be 455, not 465. I think I'm a better camera angle from over here. So now we're going to twiddle these guys. I discovered the hard way that one of them has a voltage on it. One of those trimmer screw heads in here. Oh, maybe that explains it. I think it was this can. That the last video I made an error and recorded about 20 minutes with no sound, and what I did to solve that was I just sped it up and played it back. So if you watch the last video, there's a minute or two there, high speed, me doing all kinds of stuff. One of the things that happens during that high speed part is I put a metal screwdriver in here and pow! I do it a couple of times, in fact. Pow! So that's not supposed to happen. You notice I'm using a plastic one now because I could not manage the metal one. So a little bit of excitement there, and unfortunately I really couldn't share properly in that video. Okay, we want this to go up, and we also want the ABC to go up. How can we see all this at once? I'd have to move this guy a lot. Well, let's just watch. Let's just do one. We'll make this maximum here. So I did roughly do this, and we're at the wrong frequency too. We're at 460. Maybe that's why it's at 460, because I twiddled it up there. Now we'll look at the other meter here, and I'll do the same thing. This meter should go down in either direction. Okay, one direction, down, and then bring it back. The other direction, down. Good. So what that means is both indicators are indicating the same thing. And I don't have to look at both meters. They aren't doing anything different, and they shouldn't be doing anything different. So in fact, the meter we're going to watch the ABC meter. So it's on the 5 volt scale right now. This is only 1.5 volts here. That's not much. We really want this to be way up, much higher. I'm pretty sure. Pretty sure. And let's just be a little more sure than pretty sure. I will look up 6A8 in my book here, and it will probably give us some hint as to what the bias voltage is on the two. 6A8. 6A8, come on. 6A8. Got a yellow sticky in there, come on. 6A8, grid number 1, that's the oscillator grid, and so it doesn't talk about there. Grid number 3 is, no. Grid number 2, no. Grid number 4 gives a minus 1.5 and a minus 3 as the two possible biases depending upon the plate. Plate is high in this radio. Minus 3. Grid number 4. Is there some other hint in here? Plate current. grid currents for all the different grids. Oh, that's kind of weird. Okay, there's stuff, yeah, I didn't find a thing out there. So we don't really know what this voltage should be just yet. Let's see what we can get it to. So feeding in the signal. Okay. I only did one. That's what it is. I only did one screw. Oh, also we got to get down to 455 here. Okay, 455. It's a bit of a ways to go. So what I want to do is I want to be able to hear it the whole time. Turn it in the direction I want to go. Turning up the volume on the radio. Look at that, you can still hear it. Perfect. So I should be able to just work with this. Meter. Okay, now I want to move back a can. I've done the little can here. Now we want to move back to the first can, and I'm pretty sure I need to send the signal into here. Oh! You know what I have not done with this radio? Let's just turn it off for a second. I have not wiggled these tubes at all. I have not pulled them out or pushed them in. I haven't even wiggled them. It's time to wiggle. Yikes. Kind of left something out of the deal here. So wiggling them, I'm just trying to reestablish. Ooh, doesn't that sound bad? Oh, wow, that's hot. Holy smokes, that's hot. Whew. Wow, 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 wow. Yeah, barbecue time. No, it's not barbecue time here. Today it's just above freezing outside. It's another really unsurprisingly cold day. We're supposed to be up around 18 degrees, which is a beautiful day, and we're down around 2 today. That's just terrible. Let's wiggle this guy too. This might change the entire operation of the radio. This guy's in a can. How can I wiggle him? Wiggle him by the top. I don't want to do that. You don't want to take this off. I don't want to take the grid cap off. I know. It's very loose. It's a loosey-goosey one. Let's pull it over. Pretty warm. So in my mind, that has, and from experience, that will improve the pin contacts and solve any little problem like there was. And then we also have the rectifier tube, which I hardly need to do this to, but I will. Anyway. Okay, everybody back in their sockets. Everybody ready to go again? What about this guy? He's hard to wiggle. So we're going to leave him. He seems to be working okay anyway. Okay, power back on. Dim bulb first. Just to be sure, yeah, take the... I don't need any pyrotechnics in here. Full. See what we get back. So I think we should be hearing that IF oscillator, the IF signal generator rather, seems to be gone now. Is that because what? Is that because of what? Let me turn up the signal level. Okay, no, it's a no-show. Could it be because I disconnected the input wire from the grid? That could be. Okay, we'll hook this up. Bit of noise. Let's try that. There we are. Okay. That explains why it wasn't working. Now we're back in business. We have an ABC voltage showing up. Let's just change the output here. Yep. Definitely ABC. Oh boy, what is that? I think it's this connection right here. Oh man, that's not very good. Shut it off for a sec. Okay. So these caps, what can happen here is the cap can be stuck together really solidly. And without realizing it, when you try to wiggle this off, you actually wiggle the metal cap right off the tube. We don't want that to happen, so I'm going to wedge it. This is a really hot tube, man alive. Don't touch it. So I just, even just to break the contact a little bit. Now, all I want to do is take it off and put it back on. Let's see if that wasn't the problem. Here we go again. Power on. Things are pretty quiet now. Okay. Oh, that sounds nice. And the volume right down. Is it still sensitive? No. No. So it's just a cap connection. I think we can be pretty sure of that. Now, are we in a stable? So this is why I say the first time you do an alignment, you can write it off, because this kind of stuff goes on the whole time you're doing it. And by the time you get done, you really got to wonder whether it really worked out or not. So, we want to move back. We want to move back. Move back. Pretty sure this is the grid cap we want to head for next. So we're going to turn down the output level and move this over. So there can be another problem with these caps. So the grid cap is made of steel. To not rust, they plate it with something, zinc or something like that. It's made of steel because steel has a springiness to it. Copper, no springiness to copper. You bend copper, it stays where you bend it. Bend steel, and as long as you haven't strained the metal, it will just go back. And so it makes it good for these clipping type purposes. The problem is you can't solder to steel. So the connection between the copper wire that's coming up here and the middle metal cap is done by compression. And in the long run, those things can fail. Can fail to work. They can end up like this. Okay, so now, is that really the problem? So I'm going to try to wiggle the wire without wiggling anything else. Fat chance on that, but I'm going to try. Well, that sure shut it down, didn't it? I barely moved it. So I think that's really the problem here. And the solution is to recrimp tighter. Oh, jumper. Yeah, I almost threw this right into the radio there. I had to whack it out of the air. Too bad I didn't have a longer camera shot. That would have been exciting to catch. So, fixing this now. I have to crush it. have to crush it. I have some crushers. Okay, let's get this off. I have a crushing tool. I can just get on there and crush it. I think I'm going to shut the power off while I do this, as much as I don't like turning it on and off. So this is a fairly powerful tool. Look at the arrangement in here. The result is the faces here are flat, they're parallel all the time. This is quite a tool, and it's got crushing power. It's also very threatening. Look, radio. It has this cutter here, so you know if the crusher doesn't work, cutter's coming next, buddy. We're going to crush this. You know, I'm going to take this off the tube before we end up, because I'm going to put a lot of power into this thing. I don't want the power to be pushing the top of it. Oh, that really crushed it easily. Too easily. Something went wrong there with that. You know what? There's a blob of solder on here. Looks like solder. Solder on the... Am I all wrong about that? I think I'm totally wrong about what I was saying. So it's steel, but they plated it with something that you can then solder to. Well, let's take a look with the close-up camera here before I do something unnecessary. Do something unnecessary here. So it looks like the wire, yeah, there's the wire, yep, I think I can see it. So it does look soldered. So if this isn't the actual problem, then you become really suspicious about this, but I think this is fused right on the tube just fine. Yeah, it's not loose at all. So you can't transmit any mechanical motion into the tube. I'm looking right at that wire inside the tube. Yeah. I have to stick with this. This is my best bet. I can do something about this. How could it possibly be bad? It looks perfectly good. Well, and it's still just not making good contact on the grid cap. So what I'm going to do, there it is. It's going to take a little bit of fine sandpaper here. Now there's bound to be a bit of an oxide coating on here. I don't want to grind this too much. I'm not pinching it very hard because, again, I don't want to break the cap off the tube. And this is going to leave some grit behind too. Okay, I don't really want to. So I look in this cap on here. It's shiny, clean. This one's not. This one's kind of a duller. It has a little bit of an oxide on it, I'm pretty sure. Now so why does steel rust away into nothing, but this metal doesn't? It does. It is rusting. All metals rust a bit. Just some of them produce a rust, which after, say, 4, 5, 6 molecules of thickness, kind of seals up or coats the metal. Like if you look at this. Why isn't this rusting? Because there's a layer of chromium on the surface here. That chromium doesn't rust. Steel rusts. Chromium produces a thin shell, atoms thick, on its surface, and then it stops. That's the end of the rust. The thing about steel, the rust product has about 7 times the volume of the steel it came from. So you have a little bit of steel, a little bit of rust makes a whole bunch of rust material, and the rust material pushes and grinds itself, and it does not form this beautifully adherent coating, which is what you're seeing all the time. When you look at what you think is clean, bare metal, it's not. Like stainless steel, it's not bare and clean. Some proof of this kind of stuff is you can take stainless steel. You've probably seen this in your kitchen sink. You have a stainless steel kitchen sink, and you leave a glass sitting in the sink. And when you take the glass away, if you're unlucky, there'll be a bit of a rusty ring around it. Now what's happening there, you can make this happen, by the way. Take a little, abrade the surface of the stainless steel, maybe with steel wool or anything, just abrade it, and then put the glass on it, and then come back later. When you take the glass off, you'll see steel rust in your sink, which you can clean away and be done with. What's happened is you've removed that thin coating, that thin 4 or 5 molecules thick coating, and you've allowed the fresh steel to contact water or oxygen and start the corrosion process under the glass. Well, why the glass? No oxygen, and you need something to keep the surface a little bit wet for this to work. And that's what happens. You've probably seen this in certain circumstances. Stainless steel suddenly has a bit of rust on it. Really expensive stainless steel won't do that. The coating is thicker, or whatever it is they've done with the particular alloy. Cheap stainless steels rust under those circumstances. Why did I go through all that? I don't know. I want to because in the past I was a corrosion technician, and I just like sharing stuff, so I'm sharing my knowledge about corrosion. There's nothing dragging down, well, there is these days. I was going to say there's nothing dragging down the economy more than corrosion, but right now there's something else going on in the world. But normally, much economic activity is occurring in order to replace losses due to corrosion. And you might say, what? What are you talking about? So you work hours and hours at your job to make money so you can buy a car. And then 6, 8, 10 years later, or if you're me, 16 years later, you're scrapping it because it's all rusted. Rust. Your whole car gone because of rust. Now, did I de-rust this thing? Did I solve it? Or is it still going to act up? So now when I look at the other caps, I can see they're all done the same way with solder and that. So my whole story about crimping, now I think it's true with some of these radios. I know it's true. All that there is here is a crimp. I think we're good. I think we're good now. Okay, I broke into a sweat during that. I go check my temperature. We're gonna go after the other. First, we're gonna get this radio working again. On the cap, Jim. That's what's wrong. So now we're trying to do this cap. Level down, volume down, because it might be noisy. That was my fingers touching it there. And I really hope this is the right tube. Should take less signal to come through, but now we're going through this transformer. Maybe this one's tuned way off from 455. So I may have one transformer at 455 and the other one way off, and the result is nothing's getting through. So that requires more oomph. More oomph. There it is. There it is. Okay, man. There we go. How come this isn't... How come that didn't change? That didn't move a bit. I must not be on the right tube. Oh, for sure. Oh, it's moving. So this one appeared to be on 455 already. Let's try this. Come on. This won't go in. Or is the screw so loose? Oh my gosh, it's 50 miles out. What happened there? See, this dips. I'm just turning a capacitor here. I can only go so far with it. It's not like a slug. Oh, I'm doing something stupid. This must not be right. This must not be the right connection. Let me stop and de-stupefy myself here. That might take a while. Okay, let's remove the stupid. It's the wrong tube. It's just as well though, because I got to sort out all that. Now, the actual tube is this one up here. 6A8 up here. Duh. Hear it a little bit. That's a strong signal. 455. That's very, very faint. Now back to the second IF. So we're on the 1.5 volt scale, and this is not even, well, 0.6 volts. And if we take away the signal, that's what's there anyway. Now that could be because of this connection. Let me take this connection off. Holy smokes! Just wow! Hey, you're watching this video. You're not hearing what I'm hearing. It's way louder in here. So that's the relaxed voltage. 0.6. Tune around. Oh, what was that? That's from having the volume. This radio's become very, very sensitive volume-wise. Probably this cap here is what fixed all that. There's still some kind of shorting happening here, of some sort. Stay away from that area.
It is only as we cling to Yah's promises contained in His Word that we can rest in peace, regardless of the dangers that surround us. Isaiah 26 says,
so this is being picked up, and the antenna is nothing. I have no antenna on this radio.
Trusty in Yahweh
It's this.
forever, for in Adonai Yahweh is everlasting strength. William Carey was the British missionary to India.
So on 6 inches of wire sticking out of the chassis, this radio is picking that signal up. Now that signal's from a couple thousand miles away or 1,000 miles away in the United States, but still, that's pretty impressive. That's around 9.5. Particularly strong station there. Shortwave's been really good the last few days, by the way. Through the afternoon and into the early evening here, I get lots of stuff on the 13 megahertz band, the 11 megahertz band. 9 is hopping like crazy, 9 megahertz. And later in the evening when 6 comes alive, it's not so exciting, but certainly there's a lot of stuff on 9. Well, the radio's showing good sensitivity as far as I can tell right now. Why don't we switch bands? We'll try it on the AM band here. Again, there's no antenna. If it picks something up, I'll be floored. The strongest stations are 590 and 640. We got to give it some chance, some hope. Give it some hope here. So I'm going to hook up this antenna lead. I don't think the antenna's switched down here. I'll put this onto the antenna and see what we get. One whopper of a noise. Okay, we'll put this on the other lead here. See if that goes away a bit. Yeah. Far be it from me to explain all that. Now, through this noise, can we get something? I'm going to run down and throw a switch, and that might improve the situation here quite a bit. Watch this.
191 miles an hour.
So I'm on the 15 volt scale now. So we're getting almost minus 7 volts here. That's a thumbs up. So tuning this seems to have boosted the AVC a lot. Too bad that terrible noise is on my antenna, but it is. It sounds like ignition noise from an automobile. So, where are we at? Well, okay, I got through the IF alignment process. And I did mention at the start that often a lot of things go wrong while you're doing this stage. You discover things and alike. Got through it. I'm pretty sure now the IF is properly tuned in this radio. Dial seems fairly accurate, even though I'm the one who's sliding the pointer around. So that's pretty good. What's left is to do the front end alignment. And judging by the way the radio is working, the front end alignment can't be too far out. And then assess the radio for more work or not at that point. And I forgot to look at the magic eye when it was operating. Well, we'll save that for next time too. Yeah, maybe you saw it on the video, but I didn't. Well, thanks a lot for watching. These are kind of long videos that I'm shooting, but what else have you got to do these days? Thanks a lot for watching.